You may be wondering, when do you use the standard normal distribution versus the central limit theorem? And there's two main criteria you can look at to make this choice. The first off is the type of distribution we are dealing with. When dealing with the standard normal, we know that the distribution is either normal or approximately normal, basically close enough, before going in to use the z-score. So either normal or about normal. Using the central limit theorem, abbreviated CLT, we're unsure of the original distribution. However, what we assume is that if the sample size is large enough, it's going to even out to be approximately normal, no matter what that original distribution is. So the first thing you can look at is distribution. The second thing you can look at is what we're comparing. The standard normal is going to ask about an individual, whether it's a person, animal, wait time, whatever we're comparing. But we're going to look at an individual item compared to an overall mean and standard deviation. What's the probability of one individual or one wait time being greater or less than? Whereas the central limit theorem is going to give you a sample size of whatever sample that is, sample size n, and we're going to compare that to a sample mean. What does this look like in practice? Let's take a look at two examples. Okay. A1C levels have an unknown distribution with an average of 6% and a standard deviation of 0.7%. A sample of n equals 55 is taken. What is the probability the A1C is 5.7 or lower? We're not going to find the actual probability. We're just going to ask ourselves, which of the two methods should we use? There are two key words in here. We're looking at an unknown original distribution, and we're looking at a sample size 55, and we're comparing that sample mean to the overall mean of the sample. So in this case, we're going to use the central limit theorem. The height of adult women is approximately normally distributed with a height of 54 inches and a standard deviation of 1.5 inches. Find the probability a woman is taller than 66 inches. We know that this is approximately normally distributed, so we know something about the original distribution, and we're looking at a single individual. So in this case, we're going to use the standard normal distribution. If you have any questions about these, let me know.